Hi, my name is Aiden Riley, and this is my Physics 2212 lab report on Lab 2. So the goal was to determine various interactions between charged tape, or a piece of charged tape, and differently charged objects, then model the interaction between the two pieces of charged tape on a line charge basis with the goal of determining the excess charge on one piece of tape, and also the number of deficient electrons. The charge of the tape is net positive. The the quantitative charge of the tape is 2.3704 times 10 to the negative 8th coulombs. The number of deficient electrons is 1.4814 times 10 to the 11th electrons. Note this is all off of the experimental data. Some key concepts that we'll need to know. Newton's second law, this is important for net forces, and the velocity update formula. Gravitational force, this is important because our tape is subjected to the Earth's gravitational forces. Continuing on, the electric field for a rod with uniformly distributed charge. This is important when calculating the electric field as a result of the charged tapes. This will be the basis for our model coding-wise. Next, electric forces, two formulas. The first one, the point charge formula, which is the electric force is equal to Ke, which is the Coulomb's constant, times Q1 over Q1 times Q2 over the magnitude of R squared times R hat. The other relevant one is the electric force is equal to the charge times the external electric field, and this is going to be important when calculating the electric forces between the two charge tapes. Some assumptions. Charge is evenly distributed along the tape. Air resistance is ignored, and both tapes have the same amount of charge. Our observations from Lab 1 that are relevant. The two U-tapes repel, their separation distance being 0.025 meters. The U-tape and your hand attract. U-tape and the pen also attract, since the pen is negatively charged. Thus forth, the U-tape must be positively charged. So here's the model of the tapes. The suspended U-tape, tape B, is our system. The held U-tape and Earth, which the held U-tape is tape A, are our surroundings. The present forces are, in order, the electric force created by tape A acting on tape B upwards, the electric force created by tape B acting on tape A downwards, gravity acting on tape B downwards, and finally the force of holding on tape A acting upwards on tape A. Here's some relevant experimental data: tape length, tape width, tape surface area, number of atoms, all that stuff. Some calculations. So to round off the experimental side of this, we of course had to calculate the charge. Quite simply, we just used Newton's second law to balance the gravitational and electric forces, and then substituting in with the Q times E external, we were then able to determine experimentally the charge of the tape. Looking at our code now, this part is the constants. Here's the calculation of the electric force. Here's the calculation of the electric field, which of course is important because one part of the electric forces is of course our point charge idea right there, and then the other half of it is this electric field. Finally, there's the vector arrows, which gives our both our forces and electric field direction, which is very important for properly displaying the model. Speaking of which, here is the end result. As you can see, the magnitude of the electric and gravitational force are just about equal. So the code, uh, the the charge we determined through the code was 2.5209 times 10 to the negative 8th coulombs, and the amount of deficient electrons from the code based off of that from the code was 1.5756 times 10 to the 11th electrons. Um, Note real quickly, for the U-tape to float, the net forces must equal 0, which is the main driver behind the charge calculations and why the model works in the first place. Next, some possible sources of error, which could, of course, affect both the experimental and coding side. Tape measurements could have been off, the separation distance could have been off, the held U-tape could have been non-parallel to the suspended U-tape, affecting how the charges affected each other, or how the charges would repel the pieces of tape. Some rounding errors, and of course potential charge dispersion, so just the tapes interacting with other objects and losing their charge before going into the experiment. So the important questions, the what if. So the point charge model produced a charge of 1.1667 times 10 to the negative 8th coulombs. The line charge model produced a charge of 2.5209 times 10 to the negative 8th coulombs. So the line charge model just simply has a greater charge than the point charge model. Additionally, If we look at the why are we doing it as a line charge model, the line charge model is actually more accurate than the point charge model. The reasoning behind this being that, of course, it more closely resembles real life, where obviously our charge tape is an assembly of electrons in somewhat of a line, in kind of air quotes. Um, and of course, that line of electrons is more similar to the line charge model, and of course is not one singular point charge. That is why, of course, we modeled as the line charge.